How are you doing on it? Okay.
Yeah, I think I'm doing okay.
All right. So I don't think this is yours. Did you have yours? Did you just share it with me? A new one?
Yeah, I did.
Awesome. All right. So what do we want to do first? About are the odds in the back of your book? You hear me okay, Meher?
Yeah.
Okay. Are the answers to the odds in the back of your book?
Yeah, I think so.
Okay, so first of all, I want to point out law of sines and the law of cosines. Do you know when you use which?
For law of cosines, I think you use side, angle, side, or side, side, side.
That's right.
And then for
So
law of
law of,
sines is when it's like for the other ones.
that's right. And that's because you need to have a side across from an angle in order to use the law of sines, right? So
So it would be
all
SSA.
others. Yeah, so I'm just gonna say the law of sines is have at least one side across from angle, meaning you know one side that you know, right? You have to know both of them. And so if you don't have that, you have to use the law of cosines, right? And do you remember what the law of cosines is? You want to tell me?
The law of cosines is a squared equals b squared plus c squared minus 2 bc cosine a.
Perfect. And you could write that also solve for a different one instead. Yep.
Yeah.
Okay. So let's do number one first. You want to, how about I do number one, you do number two, and we go, and then we skip a couple and then continue with the same. So number one is 2 and 45 and 4. So we are going to say B, we're going to think of this B as our A, right? We're really going to think of that one as A because that's the one that let's call that A, not B. Sometimes it just helps if you rename the variables. So for number one, you would say that A squared equals 2 squared plus 4 squared minus 2 times 4 times the cosine of 45. We know the cosine of 45 is root 2 over 2, right? So this is root 2 over 2 times 4 minus, and that's 16 and that's 4. So A squared equals, first multiply, right? So actually first let's cancel that 4 with the 2 so that we have 2. So we have 20 minus 8 root 2. And then we would take the square root of that. So A equals the square root of 20 minus 8 root 2. And it's probably okay if you write it in what, decimal form, I'm assuming.
Yeah.
Right. So that's going to be the square root of 20 minus 8 root 2. $2.947, and we're going to store that for x. You remember how to use that store button? So 2.95, I'll say. I don't know what they want you to do, what they want you to round it to, but I'll round it to 2 decimal places. And now how would I find the other angle, the other side length, or the other variables, which are angles in this case?
A equals I mean, maybe you can
So
use the law of sines.
that's right. Now that you have that side across from an angle, now you can use the law of sines. Exactly. So now what we're going to do for number one to find let's call this C, and let's call that B. And we can just rename the variables later when we're done. So we know that the sine of 45 all over 2 point, am I going to round that? 2.95. 2.95. Sine of 45 divided by 2.95 is equal to the sine of B all over 2. So that means B equals the sine inverse of 2 times the sine of 45 all over 2.95. So I'm going to do the sine inverse of 2 sine 45 over 2. Let's make sure I'm in degrees. And I'm not. I'm in radians, so I'll switch it to degrees. And it's sine inverse of 2 sine 45. So sine inverse of 2 sine 45 divided by, was it x? Yeah, divided by x. That's why I save x in there. So that's actually going to plug in the entire decimal, not just the approximation. And the answer is 28.68. 28.68 degrees. Now, how do I find the other one? How do I find?
You could use this law of sines again.
Do I have to?
Oh no, you could just subtract them from 180.
Perfect. Always do it the simplest way. So I'm adding them together and then I'm subtracting 180 and it's 106.32. Perfect. There you go. So there are my different angles, and now you go back in and you can write them what they actually are. So this is whatever that Greek symbol is, I think is what that was, 106.32 degrees. This we called A, but actually it was B, and that was 2.95. And then this angle here, alpha, is equal to 28.68 degrees. Okay. So you do number 2. Do you have paper? You're gonna do it on paper? Or do you have a pen? Do you have like a stylus you can do it on?
Okay, yeah, I can try to use the stylus.
Perfect. Do it. Here, let me give you let me clean this page off for you, or let me duplicate it
Okay,
for
let
you.
me open the Jamboard, yeah.
All right, there's that. Go on to page 2. And you can work on number 2 on page 2.
Okay, so we're doing problem number
Yeah, do number 2.
Okay.
Yeah.
Wait, shoot, this isn't the right one. Okay, I don't need to draw it again. Okay, so law of cosines equals A, B equals 3, C equals 4. 3 squared plus 4 squared minus 2, 3, 4 cosine of 30.
Good. Good start.
Okay, so cosine of 30. Oh, shoot.
That
Sine of
root
30
3 over
degrees
2.
is yeah, I am. I'm just putting it into the calculator. So cosine of 30 degrees is 0.86.
Okay. You can really just punch the whole thing into your calculator if you want.
Yeah, but I'm
As
using
long
the
as
like
you're,
the Google calculator, so
oh, okay. So it was what, 9 plus 16? You tell me what to write and I'll type it in here.
okay, now I
Minus
got
24 cosine of 30.
wait, sorry, I need to take the root of this. Okay, so it's 2.05. I don't know if I made an error, but I think
No,
I did
that's
this
right.
right.
That's right.
Okay, 2.05 is A.
Okay.
Now you can use a
So,
law of, yeah, we can use a law of sines. Okay. Um,
so is this over 4?
yeah, that's
Okay.
what I was trying to write.
Yeah. Are you sure about this time sign right
Oh
here?
yeah, no, I'm gonna try equal.
Perfect. Good. All right. Good.
Okay, so 4
Tell
times
me what.
sine 30. Okay, so that's 4 times, so this is 2 equals 2.05 sine y. So
Do you see how this problem you could just almost like in your head? I think you're probably pretty good at this. Take this 4 and put it here,
yeah,
and then get rid of that sign by doing the sine inverse.
yeah, but I'm gonna do this anyway just to make sure because I've already written it out.
Sure.
Sine inverse of this equals y. So it's arc sine of arc sine of 0.97. $77.317.
Okay. I got 70.
77.3.
I got 76.93, but that could just be a matter of
Rounding, I think.
a rounding error. I bet. Yeah.
Okay, so we
You
can
see
add
how
these two.
do you see how I didn't round mine? See how I'm using the actual full answer in there?
Oh yeah, I didn't use the full answer.
Yeah, but you can see how big of an error that could tend to have on it if you're not careful. That's why anytime you can use the full in your calculator, just use that full thing in your calculator anytime you
Okay.
can. Okay, all good.
Mm-hmm.
All right, let's try number 6 now. I'm going to duplicate this slide and we're going to do number 6. Now, why is number 6 different than the ones that we just did?
It's all sides.
Right. So the solution for this one, we're going to have to use the cosine inverse to
Uh-huh.
solve for this one, right? So we're
Yeah.
going to do number 6, and this would be, now you can still leave it like that. It doesn't really matter. Or you could solve this equation. Instead, you can write a squared minus b squared minus c squared, all divided by negative 2bc, and you're going to take the cosine inverse of that, and that's how you're going to get the angle A.
Mm-hmm. Okay.
See how I just solved it? I just moved this over, I subtracted that, I divided by that, and then I did the cosine inverse of that. Okay,
Yeah.
so you could write it, you could have that written,
Yeah,
or you could just always,
that's what I did when I did some practice problems. So yeah.
yeah, up to you. But you don't have to memorize
Yeah,
that
no, I
necessarily. You
prefer to
could
do it
always,
that way.
okay, yep,
It's
okay.
more
So cosine,
convenient.
right, cosine inverse of, and remember, A is the angle that we are trying to find. So let's say we're trying to find this angle right here, A, alpha. Okay, so
Mm-hmm.
alpha equals the cosine inverse of A would be 8, then A squared minus, you can call B and C whichever you want, all
Mm-hmm.
over negative 2 B and C, and literally just plug that in your calculator.
Okay.
So cosine inverse of that mess, cosine inverse of 8 squared minus 4 squared minus 5 squared, 8 squared minus 4 squared minus 5 squared. And maybe you want to put that in parentheses. That would have been wise. So let me insert a parenthesis in here, parentheses, because that's going to be my numerator, right? Be
Mm-hmm.
careful when you're using calculators. And then I'm going to divide that by, and I'll go ahead and use parentheses for this as well. Because if I don't, what might happen is it might only divide it by that first thing I punch in and then multiply it by the other things. In fact, most likely that's what's going to happen. So divided by, I'll even use another set of parentheses just to be super careful. Negative 2 times 4 times 5. And that answer is 125.1.
Mm-hmm.
Okay, so 125.1, and that looks about right. And then to find the other angles, I can now use the law of sines. So the sine of 125.1 divided by 8 is equal to the sine of whatever that symbol is called divided by 4. So that means that, what is that, gamma? I don't even know what that is going to be the sine inverse of 4 times sine of 125.1 divided by 8. And if I wanted, I could cancel those out, but I don't even need to do that. I could literally just punch it into my calculator very carefully. So sine inverse of, again, let's use a double set of parentheses to be careful. 4 sine of 125.0. I'm typing in what I see right above it so that I don't have a rounding error. Got it? Let's see, the sine of 125. Let's see, do I have an extra parenthesis around that? So that's going to be my numerator. So close that off twice. And then I'm going to divide that by 8. If I did that right. So approximately 24.1. We'll say 24.1. And if I check with that, whoops, didn't mean to do that. If I check, does that seem about right? Yeah, that seems about right. So how would I find the other angle?
You would just subtract it from 180.
Yeah. So you can do that on your own. Or all right, now how do I get this? I made a mistake. I need to get my calculator back. All right, you work on number 8, okay? You work on number 8 on the next page. We'll go to page 4. We're going to be doing number 8 on page 4. And while you do that, I'm going to try to figure out why I get that calculator back. Can't remember how I got it in the sidebar. So do 8. I'm not having you do 7 because that one looks like you could. That's the answers in the back. So maybe you can do that for additional practice on your own later. So let's try 8 right now. Okay, go ahead and write it on this page, page number 4.
Oh, page number 4. Okay. So we're solving for, we can solve for angle A first. Sorry, it kind of glitched on my screen.
Okay. Do you see it now?
Yeah. Okay. So what we're trying to solve for, a squared equals b squared. I need to rearrange my setup. A squared equals b squared plus c squared minus 2bc cosine. My stylus is kind of acting weird, sorry.
It's okay. I can see what you do. I can see what it is.
So you can just basically divide both sides by minus 2bc. A squared minus b squared minus c squared equals you could just take the cosine inverse of that.
Mm-hmm. Now tell me why this problem is easier than the other problems that we've already done, or the other one we just did.
I'm not sure.
Why are there going to be less steps for this one? Look at the
I
side
think that,
lengths.
sorry, I feel a little bit nauseous, so sorry if I'm having
Oh
trouble
no.
talking, but
Oh, that's okay.
this would have less steps because of the these two being the same number.
That's right. So you know the angles are going to be the same. This is
Yeah, the angles
isosceles.
will be equal.
Yeah, and which means you can find the third. All you really have to do is find one angle, and then you'll find the other one. Both,
Yeah.
the other two without very much work.
Mhm.
Good. So what number did you come up with?
I'm still putting it into the calculator.
Oh, okay.
$67.975 degrees. So 68 degrees.
Okay.
These two are both 68 degrees. Wait,
And
no,
what would the other
that's the
one be?
angles.
Yeah.
That's 44.
Good.
Mhm.
All right. So I'm going to let you do those. I'm going to let you do some of these. I'm just going to circle the ones. Your mom asked me to give you some additional work just to make sure you're getting it okay, practice wise. So I'm going to, all the ones that I'm circling right now on this page, go ahead and try those ones. So I already got 7, and it looks like the answers and maybe the work is in the back. And then let's do 15 and 17. Okay, so 3 more. That just do that between now and the next, before the next test, and check your answers. Okay.
Mhm.
All right. So next page. Now we're doing some word problems. So now it's just a matter of, some of the trickiest parts is kind of trying to draw the picture. Fortunately, they've already drawn the pictures for us. So this one, not really even that difficult. I'm literally just going to draw in that other line right there. And I know I'm going to have to use what, since I've got a side angle side problem. What am I going to have to use? Law of sines or cosines? Which one would you need, Meher?
Still be using law of cosines.
That's right. Right. So you're gonna have to use the law of cosines for that. So we'll just kind of talk about these. How about for number 26? I don't see the actual picture, but it
That's
says
okay. Yeah, no, that one got cut out. So, oh wait.
turn.
Okay, so
So it looks like Orlando's down here.
mhm.
Is that right? This is Orlando. This is 100. And this was Sarasota over here.
Sure, yeah.
I'm sorry, Orlando. No, hold on. No, sorry. That's not Orlando. So this is Sarasota down here, I'm guessing, right? To the right is Sarasota. And this down here is Fort Myers.
Mm-hmm.
Airplane flies from Fort Myers to Sarasota, distance of 150. So this is 150. And then turns through an angle of 50. That looks like more than an angle of 50. An airplane flies from Fort Myers to Sarasota, distance point, turns through an angle of 50 and flies. Okay, so maybe this is more like, so this looks like this is an angle of 50 right here. Is that what your picture shows? That still doesn't seem right. So the picture must just be wrong. Maybe it's like this. There's 100. There's 150. And that's a 50-degree angle turn. Maybe. Is that what we're dealing with? Something like that? No, that doesn't make sense either. Can you see the picture? What does the picture look like?
I don't have it on me.
Oh, okay.
I think we can just kind of avoid.
That one? Okay.
Yeah.
Yeah, it's hard. I can't understand the picture, but it seems like it's probably just going to be another law of cosines problem. Here's a more standard type boat problem. So number 28, let's do this one.
Mhm.
A cruise ship maintains an average speed of 15 knots going from San Juan, Puerto Rico to Barbados, West Indies, a distance of 600 miles. Okay, so it goes, I don't know if we need 15 knots. That's probably just extra information. We'll see. To avoid a tropical storm, the captain heads out of San Juan in a direction of 20 degrees off a direct headline to Barbados. Okay. Okay, so this probably says the captain normally would just go straight there, but instead he's deciding to go here and then there. Okay. 20 degrees off a direct heading. Okay. Oh, I guess we do need 15 knot speed. We're going to have to know this. 15 knot speed for 10 hours. What does knots mean again? What does 15 knots mean? Nautical, is that nautical miles per hour?
I guess
Is that what
so,
knots
yeah.
are? It's 15 knot speed for 10 hours. Okay, so we have to know what the heck that means. 15, what does knots mean? I'm gonna look it up real quick just to make sure. 15 knots to miles per hour, that would be 17.26 miles per hour. 1 knot equals 1 nautical mile per hour, roughly 1.15 statute miles per hour. Don't ask me why. Okay, so that's weird. So assuming Google is correct about that, for 10 hours, so 15 knots for 10 hours. So that would mean that it would be 176. This distance here is 172.6 miles.
Mm-hmm.
Does that sound right?
Yeah.
So, so what will we use to solve this? Tell me what to do to set up first. I'll write it. You tell me what to do. You want to tell me what to do?
Yeah. Okay, so we can use a law of cosines.
Mm-hmm. So we'll call this A over here.
Mm-hmm.
A squared equals,
A squared equals 600 squared plus 172.6 squared minus 600 times 172.6.
don't I need a 2 in there?
Yeah, sorry.
Okay,
Times cosine of A.
okay. Which means A equals the square root of that mess. Okay, so we're gonna just type that in over here. So the square root, again, you can do this all in one. Let's make sure I'm in the right, I'm in degrees, okay? So all in one would be the square root of 600 squared minus 172.6 squared minus 2. I'm gonna go minus, and then I'm gonna put all this in parentheses just again to be on the super safe side. 2 times 600 times 172.6 times the cosine of 20. So A equals 368.2 miles.
Mm-hmm.
That doesn't really make sense to me. If you look at that picture, because if I added those two numbers together, aren't I going to be smaller than 600 or no? Should be bigger than 600.
Mm-hmm.
Plus 172.6. Let me just see. Yeah. So something's not right with that calculation that we used. Or maybe with how we punched it in. Did we punch it in wrong? Yes, we did. I put minus instead of plus. Look up at the top.
Oh, yeah.
So I knew something wasn't right. So let me fix that. I hit second enter, and then this should be a plus, not a minus. Didn't even notice that I had done that. There we go. That's a much better answer. 441.77. That's much more reasonable of an answer. Now it says, through what angle should the captain turn to head directly to Barbados? So we need to find this angle right here. That's what they really want us to find. And now we can answer B right here. How long will it take? We can do that one as well. So, but now that we found this, now that we found that angle A, we can just use the law of sines, right? So let's find we'll call that C. The sine of C all over 600 equals the sine of 20 all over 441.77. So watch how you can do this kind of quickly, again, quickly in your head. You're thinking to yourself, multiply that over here and take the sine inverse of it. So it's going to be the sine inverse of 600 sine 20 divided by the answer, second answer. So C equals 27.68. So through what angle should it turn? 27.68 is the answer.
Yeah.
And then how long will it take? Well, the distance it needs to go is 441.2. 441.77. So how many 15 knot speed? So if we want to convert that to, we use a conversion factor. So we have 441.77 miles per hour, and 17.2617 15 knots. I think that's how you do it. Honestly, to be honest with you, I'm not sure. Do you have that in your notes anywhere about how to convert from knots to miles per hour? This is the conversion factor that Google is telling me. So you multiply it by 15 and divide it by 17.267. Do you have the answers for this?
Mm-hmm. Wait, I don't have the answers on me, but I know they're in the back of the book.
Yeah, look it up and tell me if we did this one right.
Mm-hmm.
388 or 383.9 approximately. Hold on a second. Does that make sense? How long will it be before? No, I just converted it to 15 knots. Well, what did I just do here? My bad. How long will it take? Well, maybe we didn't have to do all that. Maybe we just had to. No, hold on a second. Wait. Now I'm confusing myself. This is the speed that it's going in knots per hour. What is knots? What does 15 knots mean?
I'm not sure.
15 knots.
What is 15 knots? Oh, that's 17 miles per hour.
Right. It's 17.2615 miles per hour. See why I wrote this over here
Mm-hmm.
in the bottom? But now we're trying to answer the actual question. The question is saying, how long will it take? So how fast is it going? It's going 17.617 miles per hour. So I guess we didn't have to multiply by 15. All we're trying to do is find out how many hours it's going to take.
Okay, yeah.
It's sorry, I wrote this wrong. This is not miles per hour. I'm an idiot. This is miles. That's how far away it is. So if it's going 15 knots, that means it's going that much miles per hour. So 441.77 divided by 17, that's what we're going to do. So multiply that answer by 15. I shouldn't have divided by 15. No, what did I just do? This should be 441.77 divided by 17.2617. There's your answer. 25.6 hours. Because 15 knots is 17.2617 miles per hour. So the rate, distance equals rate times time, right? We're basically just dividing that by miles per hour, and then you'll get the hours.
Mm-hmm.
Sorry about that. I was confused by the whole concept of knots. So this is miles per hour. And so hours are 25.6 hours. Can you see if that's right? Can
Mhm.
you check the answer? So what's the other one that you want to do now?
Um,
I'm on the next page on the Jamboard. We have about 15 minutes left.
I think that there's some more, there's a different type of problem which I put on the last 2 pages, I think. These ones, where you have to find the area of the triangle.
Oh, okay. So do you have the formula for area?
It's 1/2 of the height, 1/2 of the base times the height.
Okay, but there's another one. There's an area. I think it's like 1/2 BC sine A or something like that. You don't know that formula? It's it's 1/2 AB sine C. 1/2 AB sine C. So it's kind of like if you have a sine, or if you have a side angle side, then you can find the area with that formula.
Yeah.
Okay, so I'll do number 2 because it looks like number 1's in the back of the book. So for number 2, your area is going to equal 1/2 A B sine C. What's the sine of 30 again? Isn't it 1/2? Right?
Mm-hmm.
So those cancel with that, and your answer is just 3. Don't even need a calculator. The area of 2 is 3. Okay.
Mm-hmm.
You try number 3. Tell me how number 3 would go. I forgot to assign one to you. Here, I'm going to circle the ones I want you to do. 25
Okay.
and 32. So for number 3, what would you do? Oh, go ahead. You're doing it. Good job.
So if it's the sine of C, sine of angle C, so that would be sine of 95. Sine of 95 degrees.
Mm-hmm.
And 1/2 2 times 3. So the
Mm-hmm.
2's cancel out. 3 times sine 95, which is 2 point, oh, that would be basically 3. So the area is 3.
What's the sine of 95?
Sine of 95? Oh, no, sorry. That would be, oh, the
It's
sine of
close to 3.
95. The
It's
sine of
close to
95
3.
is, okay, yeah.
But they wanted you to round it to two decimal places.
Oh, okay. Even if you
So
round
it'd
it to
be
2 decimal places, it ends up being 3.
no, 2 decimal places would be 2.99,
Oh, okay, sorry. Yeah, 2.99.
right? You see that?
Yeah.
So there is a difference in that. I know it's close, but
Yeah.
Pretty easy, right? Pretty easy. See how that
Yeah.
works? So not too complicated. So let's move on. Let's go to the next slide. 8, and you have 9 as well. You got about 9 minutes left. You want to pick one from here? And again, I'm going back to page 7. I want you to do the ones that I'm circling, number 1 and number 7, and you can check your answers.
Mm-hmm.
What do they want you to do here for number 7? Do they want you to find the area with that?
Mm-hmm.
Or do they want you to solve the triangle? Looks like they want you to solve it. Actually, I'm not really sure what they want you to do. I don't know if there's a formula for side, side, side area of the triangle. There might be. I think there is a formula for this. Yes. Here it is. You ready? There's another formula. If you have side, 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 so this is up here was if you had side angle side in the upper right hand corner, but in the lower left hand corner, the area of a triangle, if you have side, 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 is this. The area equals the square root of s times s minus a times s minus b times s minus c, where s
Mm-hmm.
equals a plus b plus c divided by 2. It's called the semi-perimeter, I believe.
Yeah.
Okay.
Mm-hmm.
So for number 6, I'll do number 6. I'll do number 6 down here at the bottom in red, and you can do number 7 on your own later. For number 6, s would equal 8 plus 4 plus 5 divided by 2, which is 17 halves. So the area of the triangle is just 17 halves times 17 halves minus 8 times 17 halves minus 5 times 17 halves minus 4. Now let me show you a little trick with your graphing calculator. To do this easily, first store 17 halves in your calculator for x. Okay, and now just plug in x every time instead of 17 halves. It's just a lot easier. So x times x minus 8 times x minus 5 times x minus 4. And there's your area, 8.18. And it would be whatever centimeters squared or units squared, whatever the units happen to be. Okay. Good, makes sense?
Yeah.
So that's called Aaron's formula, I believe. All right, 5 minutes. What do you want me to do? You got time probably for one more.
Yeah, I think we can do one more.
Pick anything from page 8 and 9. I think we've pretty much covered everything. Looks like there's a new area formula here, 31. Prove that
Okay,
the
we can try
area A
that
of a
then.
triangle is given by this formula.
Yeah, I think we can do that because I feel like that would probably be on a test.
Think so?
Yeah, because there's usually like those kind of problems.
So I'm assuming that what we have is A, B, C, so alpha. So let's just draw a triangle in here. So here's let's see, here's alpha, we'll call it. There's A, here's beta, and here's whatever that is, gamma. I don't even know what that's called. So they're saying prove that the area equals that. So well, we know that the area equals, we can use the formula that we just talked about. 1/2 BC, or 1/2 AB sine C. 1/2. So A B, let's see, let's just use the basic one. 1/2 base times height. So the base is A, the height, I don't know if that's the one that we're going to use. Maybe we're going to use that one, AB sine C. Let's try that one instead. The area equals 1/2 AB sine of C. So let's call this B and let's call this C. So it's 1/2. Let's see, which one should we use? Well, let's use A. 1/2 AB sine of C, which would be this one, right?
Mm-hmm.
I'll make lowercase so it's a little bit more consistent. So we want to show that B, what is B equal to? B, all right, this is probably what we're gonna have to do. We're gonna have to rewrite these. It's kind of be hard to figure out how to rewrite them. B is probably, we know that the sine of beta over B
Yeah.
equals.
Sorry, I'm being called.
Okay. Well, you see what I'm doing right here. You're probably going to have to like do a bunch of substitution. You're probably just going to have to substitute for B. So this is the sine of alpha over A. So that means that B, we're going to substitute for B. B equals A sine beta over sine alpha. So that's what we're going to plug in for B. Oh, and that might be it. That might be all we have to do. Yeah, I bet that's it. Do you see what I just did?
Mm-hmm.
So it's 1/2 A, and then I'm going to plug that in times sine of gamma or whatever that's called. So this is going to be, I'm plugging in for B, what I just solved. Sine B all over sine alpha. There we go. Which means this just equals, if I clean this up, it's going to be A squared on top, sine of beta on top, sine of gamma on top, and sine of alpha on the bottom, and 2 on the bottom. And there's your answer. Okay. So hopefully that made sense. Watch the video again if it didn't.